Alright, this is the last topic for this section called special cases. Some equations have no solution. Some equations have infinitely many solutions. So far in the previous example I've shown you an equation has one solution. But in reality, an equation can have more than one solution, infinitely many solutions, or it has no solution. Now, I'm not asking you to solve this type of equation yet, but demonstrate to you why that it can be no solution or infinitely many solution. We'll work on this example. Solve negative 3t plus 4 equal 5 minus 3t. So there are different ways to approach the problem. First I would try to combine all the variable t together. Okay? We can do that by, now for this case, both have the same coefficient, negative 3t, negative 3t. It doesn't matter. Our goal to eliminate one, right? We eliminate using the addition principle. When we use the addition principle, meaning we need to convert the term right here to 0. Okay? So negative 3t add what? Make it equal to 0. In this case, it's going to be positive 3t. Right? Negative 3t add 3t is 0. Make sure you're adding the same amount, opposite sign. And when you're adding, make sure you're adding both sides. Okay? Let me rewriting this solution. I'm just writing the original equation. Now, I'm going to adding 3t on both sides. Okay, let's simplify. Negative 3t. This is constant, we don't combine. You cannot combine different terms. This is the same term right here, t and t. So negative 3t plus 3t is 0. Don't forget the constant term. Plus 4 equal to 5. There's no constant, so 5 is 5. Negative 3t plus 3t is 0t or 0. Okay, because 0 times t is 0. Alright, so we have 0 plus 4 is equal to 4 for the left hand side. 5 plus 0 is 5 for the right hand side. Now the question is, does 4 equal 5? No. False. So that means this equation has no solution because it's a false equation. The left hand side is not equal to the right hand side. What we've been doing is that we just simplify the equation. What we got is that this left hand side is not equal to the right hand side. So thus there is no solution. Okay, so just work on this case right here. No solution because the equation is false. The left hand side does not equal to the right hand side. So here is another example. Solve. You can see x is a variable right here, right? Inside the equation. That means our goal is to solve for x. Now again, you see that x exists on both sides of the equation. So that means you need to combine, move all the x together to one side. Alright, because we have parentheses here. first thing we need is to remove the parentheses. I would like distribute this coefficient to each term inside the parentheses. 3 times 4 is 12. 3 times negative 2x is negative 6x equal 4 times, this is negative value in front of the parentheses. You can treat this as negative 1. So negative 1 times 6x is negative 6x. Negative 1 times negative a is positive a. Okay? So now we just simplify and remove all parentheses. Our next thing to do is to look like we can simplify. Let's simplify first, because you can see that the right hand side right here, you can combine 4 and 8 together. They are like terms. When you simplify, it makes the problem cleaner and less likely you make a mistake. So I strongly recommend you to simplify the equation as much as possible before you can do anything. So you don't need to simplify the left hand side because they are different terms. You can't combine them. For the right hand side, you can combine 4 and 8. 4 plus 8 is 12. Don't forget negative 6 right here. So negative 6x here on the right hand side. Now we have 12 minus 6x and 12 minus 6x. Again, there are different ways we can do that. First, I will simplify. I would move 6x together to one side. It doesn't matter which one you pick because they're both same x with the same coefficient. So to remove the 6x, that means I need to add same amount, right? Same 6x with different sign. So it cannot be negative. Opposite of negative is positive. And don't forget to add 6x on both sides using the addition principle. Okay? So you know that I'm going to add 6x to both sides, right? So let me rewrite this. 12 minus 6x plus 6x equal to 12 minus 6x plus 6x. Now we can simplify. There's no constant, only 12, so we can bring it down. Negative 6x plus 6x is 0. You can put plus 0 or negative 0. That's fine to me. 12 right here. Negative 6x plus 6x is 0. Again, you can put plus 0 or negative 0. It's fine to me. 12 plus 0 is 12. Equal to 12 plus 0 is 12. Guess what? You get 12 equal 12. That means there are infinitely many solutions. That means does not matter what x you substitute for the original equation right here. Guaranteed, left hand side will equal to the right hand side. Okay, you can try by substituting any value for x. I can demonstrate here for you. Let's pick a value. Let's say x equals 0. Okay. Substitute this to the original equation. 3 times 4 minus 2 times 0. Okay. Equal 4 minus 6 times 0, because I'm testing 0. You can pick any number you want. I'm picking 0 because it's easier to work with. You can pick 100 and negative values. So 0 minus 8 and simplify. Again, because we're not sure, right? You can put a question mark here. 2 times 0 is 0, so 4 minus 0. 6 times 0 is 0, minus 8. 4 minus 0 is 4. 4 times 3, 4 right here. 0 minus 8 is minus 8. 3 times 4 is 12. This, again, you can treat as negative 1. So negative 1 times negative 8 is positive 8, so 4 plus 8 right here. Simplify, we have 12 on the right-hand side. Left-hand side is already 12. Does 12 equal 12? Yes, true. Thus, it demonstrates that you can pick any value for x. Guarantee the left-hand side equal the right-hand side. That means there are infinite many solutions, any value x you can think of will become the solution of this equation. So as now we just finished this section 1.1, solving equations. We talked about 7 things. We talk about what an equation is. We talk about solution of an equation. We talk about the addition principle, equivalent equations. We talk about the multiplication principle, and we also cover using the principle together, combining addition principle and multiplication principle to solve an equation. And lastly, we talked about special cases where some equations have no solution or infinitely many solutions. Okay? As of now, I'm not asking you to solve these or solving equation with these type of solution yet. But I show you that for the case there's no solution, guarantee it's a false equation because the left-hand side does not equal to the right-hand side. And for this case, when you solve it, guarantee you'll get the left-hand side equal to the right-hand side. That means it doesn't matter what x you substitute to the original equation, guarantee the left-hand side equal the right-hand side. Okay? So I have the list of homework here. You can work on it. So here is the homework for section 1.1. For section 1.1, 1 to 7 odd. So you're going to work on 1, 3, 5, 7, 11 to 15 odd, 21, 23, 24, okay, 25 to 37 odd, 41 to 83 odd. Okay? And I hope my lecture helped you and prepare you for these exercise homework. Thank you.